given the percent composition and experimental molar mass, be able to determine both empirical and molecular formulas. So what you have to remember with empirical formula is, first of all, when you look at the percent composition is telling you about grams. A formula is telling you about atoms or moles, and grams and moles aren't the same thing. So what you first want to do is think of all these percents as masses, just change them to grams, and before I can come up with the formula, I have to change my mass to moles. So I take my carbon, 40.68 grams, and I need to find out how many moles of carbon is that. Carbon weighs 12.01 grams per mole. This is 3.387 moles of carbon. And I usually hang on to 3 decimals when I'm doing empirical formula, just so that I don't end up with numbers which I'm not sure if I can round off or not. Then hydrogen, 5.08 grams. 1 mole of hydrogen weighs 1.01 grams. This is 5.029 moles of hydrogen. And my oxygen, 54.24 grams. And 1 mole weighs 16 grams. So this is 3.390 moles. So now when I set my empirical formula, my ratio is 3.387 to 5.029 to 3.39. So since that's not easy to tell what that is in whole numbers, I just go ahead and divide by the smallest one. So the C and the, oh, I got the H up there twice. This is actually my O. The C and the O go to 1 each. Hydrogen is 1.48. That's close enough to 1.5. So C1, H1.5, O1. So if I go ahead and multiply that whole thing by 2, my empirical formula is C2H3O2. Okay, questions so far on just the empirical? Yeah. I haven't done the molecular yet. So this is my empirical formula so far. Oops, I just... Okay, so we did all that work just to get the empirical formula. So now the question is, what's the molecular formula? Well, the empirical formula, C2H3O2, would have a mass of 2 times 1201 plus 3 times 101 plus 2 times 16. So if this was its actual formula, we'd expect it to weigh 59.31. Anyone else get that? But what they told us up above is it weighs 118. Was there a decimal with that? 118.1 is what it actually weighs. So now if I take the 118.1 and divide by the 59.31, it's not going to be exactly 2, but it's going to be awfully close. This is 1.999. So that tells me that I should take my C2H3O2 and double it again. And the molecular formula is C4H6O4.